Today we're going to be presenting on self-organization and progenitor target generate stable patterns in planaria regeneration.
So here's what we know. Planaria are flatworms that have regenerative ability and continually renew all cells in their bodies. They contain neoblasts, which are dividing cells including pluripotent stem cells. Specialized neoblasts produce migratory progenitors that differentiate at defined target locations.
We should use planaria for our experiments then. I think we should use the eyes since they're visible and dispensable for organism viability. They're widely used in regeneration studies anyways.
So if we understand the progenitor targeting dynamics, then we can understand the anatomical changes better.
So what is our experimental design?
We will amputate the head fragment and observe morphollaxis. Morphollaxis is regeneration where the existing organs and remaining tissues retained and change their proportions and relative positions.
We can also measure the positional control genes to observe the body rescaling before anatomical changes occur. We'll mark the anterior region with NDL2 expression and the posterior region with WENT2 expression, which are known PGCs.
Since there are progenitors in the eye that continually targeting the eye when injured, we should do an experiment where one eye is taken out, then we can see if cell target the correct anatomical position or go to a position with respect to their positional coordinates.
Sounds good.
Let's go chop off some planaria heads.
Oh no, my head's being cut off. Oh my gosh, my positional control genes are going to the right positions, but why are my eyes and brains anatomically wrong? Oh wow, now my eyes and brains have shrunk and moved anteriorly, becoming anatomically correct.
Good thing that wasn't me.
Oh no, my head is being chopped off too. Ah, my right eye is being resected. Your eye looks weird.
Yes, it seems to have nucleated more anteriorly.
Now that we've finished all experiments and gotten the results, let's review and summarize what we have done in the lab after the initial decapitation experiment and decapitation with eye resection after day 3.
We demonstrated the self-organizing property of the existing eye tissue that uses molecular coupling strategies to maintain anatomical structures. As we can see here, the existing eye tissue acts as an attractor that traps eye progenitors during their migration and prevents them from reaching the target zone, defined by positional information. Therefore, the formation of an anterior asymmetric eye is not observed on partial eye resection.
After we performed the parasagittal amputation and decapitated planaria, the target zone of eye progenitors shifted and the migration path of the eye progenitors passed the boundary where the existing eye tissue can attract them. This all makes sense when it comes to explain why a third function eye was formed to the anterior side of the original.
The regenerated eye starts to form at the same place where the target zone was for the initial eye formation. You can see in the figure that in the days following decapitation and eye resection, the regenerated eye moves up front along with the target zone as the PCG domain is reestablished. If decapitation, parasagittal amputation, and eye resection are all conducted at the same time on day 1, a second regenerated eye emerges on the resection side. We can say that this happens because the reestablishment of the PCG, along with the newly formed target zone, lets eye progenitors get away from the attraction from the first regenerated eye.
In the next experiment, the molecular basis for the target zone was defined. The boundary of the slit expression zone guides the nucleation site of the eye progenitors. More specifically, medial lateral target zone movement allows new serial eye nucleation without the existing eyes shielding the new target zone. Wnt5 confines the boundary for slit expression. With Wnt5 RNAi and expansion of the slit expression zone, a second eye is formed on the lateral side and parallel to the original eye. With slit RNAi and retraction of slit expression zone, a second eye is formed on the medial side and parallel to the original eye.
While SLIT and Wnt5 set up the medial lateral body pattern, Norton helps to define the anterior posterior body axis of planaria. NOTAM is a Wnt inhibitor that is expressed in the anterior pole and is involved in the anterior patterning. RNA interference of NOTAM drives the anterior pole to lose its anterior property and leads to a targeting zone of eye progenitors moving up front.
For our final experiment, we differentiated between the targetable zone and the target zone. We found that eye progenitors migrate and nucleate to the target zone. Targetable zone is a broader region than the target zone, with access to specified eye progenitors. However, removal of the eyes in the targetable zone will not lead to regeneration because the target zone will always have the priority as the destination of migration for eye progenitors. This can be seen in Figure 6e, as transplanted eyes into the targetable zone survive because the implanted eye as a self-organizing center itself attracts eye progenitors to maintain its anatomical architecture. This is why eyes transplanted in the anterior of planaria are able to remain, while transplanted eyes into tails shrink and ultimately disappear. Thank you all for coming. So what we propose is a model for the properties governing the behavior of migratory mesenchymal eye progenitors in regeneration.
The model involves three components: an extrinsic target zone self-organization and the targetable zone.
These components allow for a better systemic level of understanding that helps explain how new tissues and organs are formed and maintained in dynamic environments such as positional coordinates changing and injury.
The existence of adaptive target zones and targetable zones could be a broadly used strategy by diverse developmental and regenerative processes to form and maintain complex self-organizing modules. Thank you.
So that concludes our presentation.
Thank you for listening. Do you have any questions?
Great job, guys. A++. You really captivated the audience.